Okay, in this video we're going to be talking about our second of two reaction types, which is called neutralization. And in addition, we'll be talking about something called salt hydrolysis, which is whether the products of a neutralization reaction will be acidic, basic, or neutral, and how to figure that out. All right, so let's start off by talking about what a neutralization reaction is and when we use it. Right, so proton transfer reactions we used when the base was not a hydroxide. That means that neutralization reactions get used whenever the base is a hydroxide, so it ends with OH. These reactions are just double replacement type reactions. They're double replacement, but they follow a very specific pattern in that the acid plus the base will always yield a salt, which is an ionic compound, and water. Always water. Now, it may, during this, be more helpful for you to write water as HOH instead of H2O, so that it can help you with the replacement a little bit, but that I'll leave to you guys. So as an example, we have nitric acid, HNO3, reacting with sodium hydroxide, NaOH. So what we're going to do is we're going to do double replacement. Remember, in double replacement, all we do is we do our first two parts of foil. So the outer two combine and the inner two combine. Right? So if I look at the inner two, I'm going to have Na, my positive ions, always written first, combining with NO3 minus. Na is plus 1, NO3 is minus 1. They just cancel out. And then I get H combining with OH minus. H is plus 1, OH is minus 1. They cancel out. We form HOH or H2O in this case. Remember from your double replacement, the only time a subscript carries across the arrow is if it's part of an ion on your chart of charges. Right? So that means, for example, if we do H2SO4, the 2 from the H2 doesn't go across the arrow. That's the reason why we balance equations later on. Right? But this is our equation. Nitric acid plus sodium hydroxide will form sodium nitrate, which is our salt, and water. Now, it would be kind of nice to know whether sodium nitrate was acidic, basic, or neutral. Right? That way, when we do our titration experiments later on, we know which indicator to choose for the reaction. So here's how we figure this out. To compare or to find the pH of a salt, all we do is we compare the strength of the acid and the base that had to react. Right? So if you have a strong acid and a strong base that both break up 100% of the way, they tie. So if they tie, the salt will wind up being neutral. If we take a strong acid and react it with a weak base, well, because the acid is stronger, the salt that we form will be slightly acidic. Similarly, if we take a weak acid, react it with a strong base, the base is stronger, so the salt will be slightly basic. Now our last combination, which is weak, anybody's guess. Unless you break into the actual equilibrium constant values of the acid and the base, you won't be able to determine the pH of a salt formed by a weak reaction, which is one of the reasons why in a chemistry lab we generally never do them, so you don't have to worry about doing a weak acid with a weak base. It will always be one of the three combinations above. Right, so if they're both the same strength, strong and strong, they tie. If they're not both strong, whichever one is stronger wins. So what we'll do is we'll do an example of this. The salt we'll work with in this case is going to be aluminum nitrate. Now, what we're going to have to do for this is we're going to have to write the reverse replacement reaction. So I'm going to start off with AlNO3 as one of my two products. And my other product is going to be water, which I'm going to write as HOH, just to make the replacement a little bit easier. Undoing a replacement is the same as doing it in the first place, right? So we're going to do outer two and inner two. Just keep in mind, the subscripts don't carry across the arrow unless they're on your chart of charges. Right, so what I'm going to do is I'm going to take the outer two. The outer two are going to be aluminum and hydroxide. So I'm going to have Al With OH, Al is plus 3, OH is minus 1. Since the charges don't cancel, I'm going to drop and swap, and I get Al, OH in parentheses 3. Now I'm going to take the inner two. I'm going to take my H plus and my NO3 minus. Again, that second subscript doesn't come across. H is plus 1, NO3 is minus 1. They cancel, so it's just HNO3. And if you wanted to, you could balance this equation out. It's not that hard to do. Right? But realistically, what we want to do here is we have our acid is HNO3, nitric acid. Nitric acid is a strong acid. Our base is aluminum hydroxide. Aluminum is not in group 1, nor is it in group 2, which means aluminum hydroxide is a weak base. A strong acid reacting with a weak base will produce an acidic salt. And to demonstrate this, I've got a little demonstration from the lab. What I have here is I just have a beaker that has some aluminum nitrate solution in it. I have a pH test strip and the vial that will let us read it. I'm going to take the glass stirring rod. I'm just going to dip it onto the pH testing strip, and we can see that the pH testing strip turns a little bit red. I'm going to match it up as closely as I can with the numbers on the container. And what I wind up with is a pH of about 4. pH of 4 is less than a pH of 7, which means that our aluminum nitrate salt is slightly acidic, just as our prediction told us it would be. Right? So this is neutralization and salt hydrolysis. In our next video, we're going to start talking about some calculations involving pH and pOH and concentrations and how to interconvert between all of those.